Good evening, and welcome to Late Night Science, a quiet space where we drift together through the mysteries of the universe, slowly and softly, like starlight crossing a sleeping sky. Wherever you are, perhaps in bed, headphones cradling your thoughts, or looking out at the night through the gentle reflection of a window, I invite you to settle in. Take a slow breath. Let the day release its weight. Tonight, we begin at the very beginning, before beginnings even existed, before there was light or time or memory. From the silence before creation, something whispered itself into being, a single proton, the first heartbeat of existence. If you're joining this journey for the first time, welcome to this circle of slow science and gentle wonder. And if you've been here before, returning again to these calm late hours, thank you. You are part of this constellation now, a quiet community, adrift together in curiosity. As we begin, let me know where in the world you're listening from. Somewhere under the same cosmic canopy, your presence ripples softly through this story. And if you find peace in this stillness, you can always like and subscribe, not as a gesture to the algorithm, but as a way of keeping this tranquil current alive. Together we build a little observatory of calm in a noisy universe. Now close your eyes if you wish. Imagine everything, but absolutely everything, gone. No stars, no atoms, no space in which to float. No before, no after. Not even the dark, because darkness requires space for shadows to fall into. What remains is not even emptiness, for emptiness implies a container. What remains is the absence of presence itself, a quiet so total that silence does not yet have meaning. This is not a void you can picture. It has no edges, no boundaries, no place to stand. And yet, from within this unimaginable stillness, the entire universe was folded, waiting for a tremor. Physicists call it the quantum vacuum. Not a true nothing, but a restless sea beneath being, where potentiality hums even when nothing seems to exist. It is a strange paradox. The vacuum is never truly vacant. Even when stripped of matter, it seethes with ghostly fluctuations, tiny blinks of energy appearing and dissolving before reality can catch them. This is the closest we can come to nothing. And yet, it is this nothing that dreamed of everything. You might imagine it like an infinite ocean, utterly still on the surface but beneath. Invisible currents stir, invisible but inevitable, patient but irrepressible. In that still sea of quantum potential, time had not yet begun. Without change, there is no ticking, no movement, no sequence. Time and space were concepts still wrapped together, unspooled only when energy began to move. So in this primordial hush, the laws of physics, our dependable guides, were silent too. They did not yet exist. There were no rules to break, no constants to measure, no light to reveal contrast. But within that absence there was the possibility of law, of pattern, of rhythm waiting to be born. It's as if the universe, before becoming visible, was humming a tune below hearing, a vibration on the edge of being, longing to express itself. And then it did. Not with a thunderclap, not with explosion or noise, but with a shift so subtle that silence itself began to move. In that movement was energy. And energy once stirred can never quite rest again. It was a flicker of imbalance, a gentle asymmetry that cracked open the stillness. Like a seed swelling underground unseen, the nothingness began to differentiate within itself. The indistinguishable became distinct. The first boundaries formed, and with boundaries came relationships, directions, possibilities. In that trembling instant, the fabric of reality, space-time, stretched itself awake. Imagine standing at that threshold, though standing and there are meaningless. Yet imagine the sensation. The temperature was beyond imagination, the density beyond comprehension. Everything that would ever exist compressed into a point smaller than a proton. Yet from that impossible compression, the first light began to strain toward freedom. The stillness that contained everything could no longer hold its own weight. Creation was not commanded into being. It slipped, softly but inevitably, from potential to presence. If you listen closely, this story is not only ancient, it is intimate. Every particle in your body, every proton in your blood, carries the memory of that first awakening. You are, in a very literal sense, an echo of the universe remembering its own birth. The atoms that shape your bones are made from that first trembling in the void, the same whisper that turned absence into existence. Even now, billions of years later, that quiet hum remains woven into the structure of everything. There's something profoundly human about this mystery. We seek beginnings because we are creatures of time. But what if the universe itself had to learn time, to breathe, to sequence, to age? In the first instant, there was no before for it to arise from. The question, what came before the beginning, is like asking what lies north of the North Pole. It is not that there is no answer, only that the question dissolves when faced with the geometry of reality itself. And yet, the mind still reaches gently into that silence, wanting to touch the edge of creation. Scientists, poets, and dreamers have all tried to name this moment. Some call it the Big Bang. Though bang is a poor metaphor, it was not an explosion, but an expansion, a smooth unfurling of space-time from an infinitely small, infinitely dense state. Others imagine it as a breath, the cosmos exhaling itself into being. Whatever image you hold, let it be slow. Let it unfold like dawn. Even the word nothing feels too harsh, too cold for what this was. This was a nothing full of promise, the way soil holds the scent of rain before a storm. Within that stillness was the entire story of everything. The rise of galaxies, the forming of oceans, the quiet pulse of thought. All of it already written into the mathematics of potential. If you could read that code, if you could peer into the silence before creation, you might see the first proton waiting, small perfection, patient as a heartbeat, ready to anchor the universe in being. So tonight, as the world outside drifts towards sleep, imagine that stillness, not as far away but within you. The same calm before creation hums beneath your awareness, the same balance between motion and rest, between emptiness and existence. Perhaps in that sense the universe never truly began. It is still beginning, over and over, through every moment of awareness, every flicker of thought, every breath drawn from the quiet that once contained everything. And somewhere within that eternal quiet, energy stirs again. A whisper moves through the dark. The first light gathers its courage. The silence begins to tremble. And in that trembling, something forms, something small, something eternal. The first proton, the heartbeat of existence. There is a silence so deep it becomes a kind of sound, a hum below awareness, an ache in the air that feels like waiting. Out of that waiting, the universe drew its first breath. Not with noise, not with fire, not yet, but with a tremor. An infinitesimal quiver that rippled through nothingness itself, so small it had no place to occur, no time to unfold within. And yet that trembling changed everything. What we call nothing is not the clean, vacant emptiness the word implies. In the language of physics, the void is alive with possibility, a seething field of invisible energy balanced on the edge of being. Even in its stillest state, the quantum vacuum vibrates with uncertainty, each point of space flickering between existence and absence, a restless fabric that cannot stop dreaming. Imagine a canvas that paints and unpaints itself in every moment, colors appearing only to fade before they can be seen. That was the first motion, a whisper in the dark. The vacuum remembering that it could move. To our senses, such motion would have been undetectable, smaller than the smallest distance, faster than the briefest instant. But physics listens deeper than we can imagine. It tells us that this fluctuation was not an accident but a necessity. In the quantum world, uncertainty is not a flaw. It is the source of creation. Even in perfect stillness, particles and antiparticles blink into and out of being, borrowing energy from the vacuum like fleeting thoughts. Most of them vanish, cancelling one another out, returning to the quiet. But once, perhaps only once, imbalance tipped the scales. A fluctuation that did not fade, a breath that did not exhale. That moment, that faint tremor, was the first asymmetry. It was as if the void exhaled just a little too far, and in doing so created room for existence to expand. Out of that small permission came energy, wild, radiant, uncontainable. The breath of creation surged outward, carrying with it everything that would ever be. It was the birth of space-time itself, an unfolding so rapid and absolute that the word explosion fails to capture its elegance. There was no outside for it to expand into. Expansion was the creation of outside. The universe wasn't growing in space. Space itself was growing. You might picture it as the surface of a soap bubble, smooth and glowing, stretching as more air fills its heart. Or perhaps as a deep inhale that has never been released, still expanding even now. In that first breath, the universe inflated, unimaginably fast, unimaginably vast. A trillionth of a second after that trembling, it was already larger than entire galaxies. The silence was replaced by motion, the void by vibration. Nothing had remembered how to breathe. What caused that first quiver? We cannot say for certain. Some physicists believe it was a random fluctuation in a quantum field, a spontaneous spark of energy with no cause, because cause had not yet been born. Others imagine that it was inevitable, the statistical certainty of infinite possibility eventually finding form. Still others wonder if our universe is one bubble among many, each born from its own trembling in the eternal sea of the multiverse. But beneath all the speculation lies a shared awe that something, anything, could arise without precedent. That being could blossom from the pure potential of non-being. Energy rushed outward, condensing and diffusing at once, as though the universe were exhaling itself into awareness. Temperature soared to impossible heights, over 1 billion trillion degrees, so fierce that no form could survive. Yet, within that firestorm, structure began to whisper itself into the chaos. The laws of physics, still molten and forming, took their first shapes. Gravity stretched across the newborn fabric, electromagnetism hummed into being, and the strong and weak nuclear forces began their quiet negotiation for balance. These were not separate creations, but different notes in one emerging harmony, 4 chords of a symphony that would define everything to come. And as this orchestra of forces tuned itself, the energy of that first trembling began to diversify. It fractured into particles, quarks and leptons, bosons and photons, an invisible rain of substance that filled every nascent inch of space. Each appeared and vanished, unstable and free, flickering between presence and potential like fireflies at the edge of dawn. But their dance was not random. There was rhythm hidden in their chaos. For every flash of energy, a partner of opposite charge appeared. Matter and antimatter entwined in perfect symmetry. They met, collided, and vanished again in light. The universe for a moment shimmered between something and nothing. Balance almost restored, almost. In that delicate balance, a tiny imperfection occurred. Perhaps one extra particle of matter for every billion pairs that cancelled each other out. That minute unevenness was the seed of everything that would follow. Every star, every atom, every thought is born from that one small refusal to balance perfectly. Without that asymmetry, the universe would have blinked out as quickly as it appeared, dissolving back into the formless quiet. But because of that flaw, the music continued, So the universe expanded, cooling as it grew. Energy condensed into matter, matter clumped into patterns. The cosmic breath that began as a whisper grew into a symphony of creation. A rhythm still echoing through the microwave background that hums across all of space, the soft afterglow of that first exhalation. Even now, that ancient sound travels through us, a relic of the moment when nothing trembled and became everything. If you could listen deeply enough, past the hum of electricity, past the beating of your heart, past even your thoughts, you might sense that faint background sigh, a cosmic memory murmuring through the air. It is the breath that never stopped. The same expansion that began at the beginning continues still. Space stretches between galaxies, even as you breathe this sentence. Every inhale you take mirrors that ancient rhythm, expansion and release, silence and sound, nothing and something. You are, in your breathing, a miniature echo of creation's first motion. It is humbling to think that this entire story, all of history, every possibility, began not with thunder but with a tremor too small to be seen. A single quantum sigh, the void remembering its own restlessness. Energy, uninvited yet inevitable, arose because the universe could not remain still. From that restlessness came light, from light came form, and from form came awareness, you hear, listening to the afterglow of a birth that still reverberates across time. So when you look up at the night sky, scattered with quiet stars, remember, you are witnessing the breath of creation still unfolding. The void has never truly gone silent again. Its trembling continues, shaping galaxies, stirring particles, vibrating in every atom that builds your body. The same whisper that once stirred nothingness now lives as motion within you. And somewhere, deep within that ongoing exhalation, new tremors begin again. The next whispers of being forming in the quiet. The silence that once breathed the universe into motion is not finished speaking. There are moments in time when stillness can no longer contain itself, when waiting becomes movement and silence bursts into sound. The universe had been breathing in, gathering tension from its own trembling, and now, in an instant beyond comprehension, it exhaled. Fire bloomed from emptiness, heat so vast, so absolute, that no concept in the human mind could cradle it. This was not light as we know it, not the gentle gold that spills through our mornings, but pure energy, unfiltered and unbroken, expanding faster than light could think. In that first instant, less than a heartbeat after nothing became something, reality was a storm, a fierce, incandescent sea of energy, so dense that space itself bent under its weight. Temperatures soared above 1 trillion degrees, so hot that matter could not yet exist. Only light, only motion, only a ceaseless roar of radiation cascading through the newborn cosmos. Yet within this firestorm, patterns began to whisper themselves into form. Energy in all its chaos was not entirely chaotic. It carried within it the mathematics of balance, the seeds of order hidden inside the flames. You might imagine it like molten glass spinning on a craftsman's rod, shapeless at first, glowing, unpredictable, yet destined to cool into something delicate, structured, and transparent. The early universe was that glass, incandescent and fluid, carrying within its turbulence the promise of clarity to come. But for now, it burned. The laws of physics, gravity, electromagnetism, the strong and weak nuclear forces, had already begun to separate like threads untangling from a single strand of golden light. Each force defined how the energy would move, collide, and create. Gravity began its patient work, whispering to energy how to gather. The strong force fierce and loyal, prepared to hold particles together once they could exist. Electromagnetism shimmered, eager to bind opposites, and the weak force, subtle and quiet, waited to guide transformations. Together they composed the grammar of creation, a language through which the universe could begin to describe itself. At about 1/10,000th of a second after the beginning, the universe was expanding at a staggering rate, and the fire was already beginning to thin. Every particle of energy was being flung apart, yet every movement left an imprint, a pattern, a vibration, a record of where it had been. These vibrations are still here today, woven into the cosmic background radiation, the faint and ancient glow that fills all of space like a memory of fire long extinguished. That glow is not metaphorical. It is real light, billions of years old, still traveling outward from that first storm. It is the echo of the universe's first words. And what words they were, not sentences of sound, but equations of energy written across space-time itself. The first light was not light in the visible sense, but pure photons, radiation beyond any spectrum we could see. Their pressure shaped the geometry of the young cosmos, their collisions creating the scaffolding upon which matter would one day rest. It was in these interactions, photon with photon, wave with wave, that the blueprint for all structure began. Energy has a strange habit of seeking form. In the first fractions of a second, as the universe expanded and cooled, energy began to condense into particles. Quarks appeared, the smallest known building blocks, ephemeral and restless, drawn together by the strong forces invisible glue. They collided and scattered in a brilliant storm of creation and annihilation, each moment producing and erasing forms too quickly to name. Out of this dance, some quarks found one another, bonded by that fierce nuclear embrace that grows stronger the farther you pull. These trios of quarks became protons and neutrons, the first stable entities in a universe of fire. For the first time, something lasted. Something survived the inferno. The proton, that quiet heartbeat of matter, emerged from the light, not in isolation, but in billions upon billions of copies, identical and unyielding. Each one a small success against chaos, each one a promise that form could endure. Yet even then the balance was fragile. The universe was still far too hot for atoms to exist. The photons battered everything relentlessly, breaking bonds as soon as they formed. Matter could only hide for now, suspended within a blinding sea of light. And this light, this primal radiance, did not merely illuminate, it sculpted. As the universe expanded, the interplay between radiation and matter determined where density would rise and fall, where clusters would form, where emptiness would stretch. It was light that gave shape to darkness, that defined the valleys and peaks of the cosmic landscape. Even now, when we map the structure of galaxies and cosmic filaments, we are tracing the fingerprints of that first light. Every glowing star, every shadowed void carries the geometry born in those incandescent moments. There is something poetic about that the first light was not gentle illumination, but creation itself. It was a light that didn't just reveal what was there, but made there possible. In its fire, time found direction. In its pressure, space found shape. Every future sunrise, every glimmering candle, every soft reflection of moonlight on water, all are descendants of that original blaze. Yet in all its grandeur, that light was fleeting. As the universe continued to expand, it cooled, the radiant. Energy thinned, its brightness stretching across the widening fabric of space, redshifting into gentler frequencies. What was once blinding fire became invisible heat, still present but softer, woven into the background hum of reality. Within a few short minutes, the temperature had fallen enough for the first nuclei to form, the beginnings of hydrogen and helium, the elemental breath that would one day feed stars. The fire had given birth to endurance. From the storm of photons came the steady glow of atoms to be. Energy had begun to remember stability. Even so, the memory of that first light remains in everything. Every photon that reaches your eyes, whether from a candle or a distant galaxy, is part of an unbroken lineage stretching back to that first radiant instant. Light has never truly stopped traveling. It only slows, transforms, reflects, refracts. Every flicker we see is the continuation of that first ignition, that first act of the universe declaring, "I am." And when you close your eyes at night and see behind your lids the faint shimmer of imagined stars, you are, in a way, remembering it too. The human mind is made of matter that once swam in that same fire, particles forged in the blaze of nothingness. You are not looking at the light, you are looking from it. You are part of its long unfolding. So the fire burns on, not as destruction, but as persistence. The first light became the first form became memory, and memory became awareness. In that sequence lies the story of everything. Somewhere the universe is still expanding, still cooling, still writing its story in the language of light. The afterglow of that first ignition stretches infinitely outward, gentle now, faint, but never gone. And in the quiet of this continuing fire, something begins to take shape within the glow. The first patterns of substance, the first outlines of form. Chaos begins to settle, to find rhythm, to hum softly toward order. The storm is far from over. But from its heart, something new begins to stir. The first whispers of matter gathering their strength from the fire of emptiness. The fire of creation had begun to cool, but not to calm. From the radiance of that first light emerged a sea, not of water, but of energy so dense and alive it moved like liquid. The universe, barely a heartbeat old, was an ocean of particles. Quarks, leptons, photons, sparks flickering in and out of existence, each one a brief flare of being. They collided, annihilated, and reappeared in an endless storm, a dance of birth and disappearance where matter and light were indistinguishable. It was chaos, but not without rhythm. A turbulence that carried within it the pulse of something waiting to form. Imagine it, not silence, not darkness, but an incandescent tide of motion. There were no shapes, no edges, only the relentless surge of particles colliding at unimaginable speeds. Everything existed as potential, brief flashes of quark trios forming and then dissolving under the violent heat. Each moment was both creation and destruction, as if the universe were practicing existence, learning the pattern it would one day keep. The energy of this ocean was so intense that the fabric of space-time itself quivered. Temperature ruled everything. More than 1 trillion degrees, so fierce that no particle could hold its shape for long. Yet, amid the chaos, patterns began to whisper themselves into being. Probability, that quiet sculptor of the cosmos, began to favor certain arrangements. Some combinations of quarks lasted a little longer, held together a little tighter. In a storm where everything blinked and vanished, these fleeting structures were like bubbles that refused to burst. The first hints of stability. The quarks came in flavors. Up, down, strange, charm, top, bottom. Names that sound playful but hide profound complexity. Each one carried its own identity, its own weight and charge. The lightest among them, the up and the down, were the most common, filling the ocean like sand grains stirred by a current. They were the building blocks that would someday form the proton, though that destiny was still far away. Hidden beneath waves of heat and motion, and binding them together, unseen yet omnipresent, were the gluons, particles of pure force, the messengers of the strong interaction. A strong force is unlike anything in our human world. It does not weaken as distance grows. It strengthens, pulling harder the farther it stretches. Imagine two magnets that resist being separated, not with steady tension, but with increasing insistence, as if the universe itself refused to let them part. In this ocean of particles, gluons were the invisible threads weaving through the waves, binding quarks into trios, uniting opposites into unity. Each quark carried a color charge, red, green or blue, not colors of sight but of force. And like the hues of light blending into white, only the perfect balance of three could form stability. When red met green and blue, the result was colorless, the first whisper of equilibrium in the roaring sea. Nature, even in chaos, sought balance. In those rare, fleeting moments when three quarks locked together under the pull of gluons, something profound was born, a prototype of the proton, a nucleus of endurance in a storm of impermanence. Yet these first attempts were fragile. Photons, the particles of light, still flooded the universe in overwhelming numbers. They collided with everything, shattering fragile bonds before they could settle. The ocean seethed, particles transforming, disappearing, being reborn. Every instant was a churn between order and disorder. But beneath the surface noise, something was changing. The balance of energy began to shift. As the universe expanded, its temperature dropped ever so slightly, and with every fraction of a second, the chance for stability increased. Leptons, lighter particles like electrons and their fleeting cousins, the neutrinos, darted through this ocean, almost indifferent to the chaos around them. They were the quicksilver spirits of this early cosmos, ghost-like and agile, interacting rarely, slipping through collisions like whispers through wind. Each played a quiet but crucial role, the neutrinos carrying energy away, helping to cool the cosmic sea, the electrons waiting for their future partners, the protons, to form atoms that would one day build everything we know. To witness this time is to witness energy becoming intention. It is the universe rehearsing permanence. Each spark, each collision, was a vote cast in favor of structure. And though destruction outweighed creation by 1,000-fold, the survivors, the brief alliances of quarks, were teaching reality how to last. In their persistence was a foreshadowing of everything to come. Physicists often describe this era with equations and probabilities, but if we slow those numbers into something we can feel, it becomes a story of balance learning to hold itself. The strong force, the binding heartbeat of matter, was testing its strength. The quarks were exploring companionship. The universe, in its infancy, was discovering the grammar of existence. Attraction, repulsion, combination, endurance. We might think of it as chaos, but perhaps it was more like music. Dissonant, yes, but not meaningless. Every collision was a note, every particle a vibration, every fleeting bond a phrase in an unfolding symphony of form. It was a composition too immense for human time, yet in every instant, a theme repeated: unity seeks itself. As expansion continued, the energy density fell further, and suddenly the impossible became possible. Around 1/10,000th of a second after the beginning, the temperature dipped just enough for protons and neutrons to survive. These were not accidents, not random survivors of a dying storm. They were the natural consequence of the universe cooling into coherence. The ocean that had once been chaos was beginning to crystallize into meaning. But before that calm could arrive, the storm still had lessons to teach. Matter and antimatter were still annihilating in brilliant flashes of energy, vast waves of light born from their mutual erasure. Every annihilation left the cosmos slightly less crowded, slightly cooler, slightly more ready for stability. Yet, for reasons we still don't fully understand, matter had the faintest advantage. One extra particle for every billion pairs that destroyed each other. It was that imbalance, tiny and inexplicable, that allowed anything to remain. Without it, the universe would have collapsed back into pure light, its story unfinished. In that ocean of destruction and creation, this unevenness was everything. The surviving particles, those few precious billions that outlasted their antimatter twins, became the ancestors of stars, planets, oceans, thoughts. From that subtle imperfection, permanence was born, so the ocean began to calm. The collisions grew rarer, the waves softer. The density of photons still outnumbered matter by vast orders of magnitude, but the seeds of endurance had taken root. The proton, small, patient, indestructible, was about to rise from the fire, born from the storm that sought its own stillness, and as the universe drifted into its next breath, that endless sea of light shimmered with quiet purpose. Chaos had not ended. It had learned direction. The stage was ready, and the first building blocks of all reality waited, held together by invisible threads glowing faintly within the cooling tide. From this ocean of particles, the universe would soon sculpt its first true structures. The proton, the neutron, the beginning of matter as we know it. The storm was nearly over. The calm was coming. Somewhere in the cooling twilight of the newborn universe, amid the soft, fading roar of light and annihilation, a miracle of pattern began to endure. The chaos of the early ocean found its first steady rhythm, a moment when three tiny entities, fragile as whispers, discovered that together they could last. Up, up, and down. Three quarks, bound not by choice, but by the invisible insistence of nature itself. They would become the proton, the enduring heart of every atom to come. In their union lay the seed of all structure, all chemistry, all life. Quarks are unlike anything else in existence. They are not things you can isolate or even truly imagine. They live in confinement, forever hidden, forever held within the embrace of their own force. To understand them is to peer into a paradox. The closer you try to separate them, the stronger the bond becomes. This is the strange poetry of the strong force, a law written not in distance, but in devotion. In every attempt to pull quarks apart, nature responds not with weakness, but with defiance, tightening its hold until energy itself becomes matter once more, birthing new pairs of quarks, rather than letting anyone drift alone. The world they inhabit is one of color. Not the colors of light that our eyes know, but an abstract harmony of charge. Red, green, blue. Three shades that only together can make neutrality, the pure white of balance. Each quark carries one of these charges, and only in combination do they cancel into completeness. In that trinity lies stability. In that symmetry, survival. Nature insists on the full chord. A single note cannot stand. The proton is that chord made real. Three quarks woven together in a perfect balance of color, charge, and motion, their energy trapped and sustained by the constant exchange of gluons, the carriers of the strong force. Inside this tiny structure, space itself trembles with activity. Gluons dart ceaselessly between the quarks, binding them with threads of energy that never loosen. The proton is not a solid bead of matter, but a storm in miniature, a blur of motion where particles and antiparticles flash into existence and vanish again, where the vacuum itself contributes to the mass. Its boundaries are not edges but probabilities, its solidity an illusion crafted by confinement. What we call matter is at its core a vibration of energy locked in self-perpetuating rhythm. The strong force is unlike the forces that shape our visible world. Gravity fades with distance. Electromagnetism weakens when charges move apart, but the strong force deepens its hold the farther it stretches, as if drawn by longing. This inversion of logic, this law of intimacy, ensures that the universe has a foundation that cannot fracture. The proton, born of that unbreakable intimacy, has endured for nearly 14 billion years without decay. It is not eternal in theory, but in practice, it may as well be. Think of what this means. Every atom of your body, every grain of dust, every star, every galaxy is built upon the persistence of these quark triplets. They are the smallest symphonies of endurance. 3 notes, endlessly resonant. Each proton a song of unity. Each neutron a quieter harmony of up, down, down, a sibling in the same cosmic family. Together, these trios became the scaffolding upon which the universe would construct its visible self. In those early moments, countless quarks roamed free in the cosmic plasma, unable to hold their bonds for long. The heat was too fierce, the gluons too agitated. But as the expansion continued and the temperature dropped below 1 trillion degrees, the strong force finally triumphed. Quarks found partners, color charges balanced, and for the first time, the universe contained something that would last longer than an instant. The Hadron Epoch, the age of bound particles, had begun. In a way, the universe was learning its first lesson in cooperation. Individual freedom led only to disappearance. Connection meant survival. 3 quarks together became something more than the sum of their energies. Their mass was not simply the weight of their parts, but the energy of their binding, the restless dance of gluons between them, the shared persistence that turned motion into matter. In this way, the proton was not only a product of physics, but of relationship. It is the first proof that the universe endures through connection. The quark trinity is a kind of sacred geometry at the smallest scale. The up quarks, lighter and more agile, lift the balance of charge. The down quark grounds it. Together they form the +1 of the proton, the heartbeat of all chemical life. In the neutron, that balance shifts. 1 up, 2 down. And from this subtle rearrangement, entire worlds of difference arise. Without neutrons, atoms could not bind. Without protons, there would be no atoms at all. Creation rests on this simple duet between 2 kinds of quarks arranged in 3s, endlessly repeating across all matter. If you could slow time enough to watch inside a proton, you would not see stillness. You would witness constant exchange, or gluons flickering between quarks at nearly the speed of light, creating a dynamic web of tension. It is not so much a particle as it is a storm held in a loop, a perpetual balance of motion and containment. This motion gives rise to most of its mass, a truth that humbles our old intuitions about matter. The solid things we touch, the firm ground beneath our feet, are mostly energy, energy bound into endurance by the dance of the quark trinity. And though we describe these things with the language of science, there is something deeply human in their symmetry. The idea that unity is stronger than isolation, that diversity of color leads to wholeness, that strength arises from mutual confinement. These are not just physical truths. They are echoes of something universal. In every proton lies a quiet metaphor for survival, that the smallest things, when held together, can withstand the vastest storms. As the universe cooled further, these tiny trios filled the cosmic sea, stable and plentiful. Protons and neutrons drifted through the cooling plasma, colliding with electrons and photons, waiting for the right conditions to form the first atoms. But for now, they simply existed, silent, unyielding, indestructible. The chaos had learned form. The storm had learned stillness. And in every proton, the lesson of the early universe was written in color and confinement: hold together or vanish. So here, in this quiet chapter of cosmic history, the foundations of everything were set. The quark trinity had found its balance, the strong force its purpose, the universe its first architecture of permanence. What was once a roaring sea of energy had settled into structure. From three quarks bound in harmony, all of reality would unfold. And as the light continued to stretch across the expanding void, the newborn protons shimmered like embers in the cosmic dark, the first eternal forms in a universe still finding its breath. Somewhere in that glow, the story of matter had begun its long, patient unfolding. There is a power in the universe so fierce, so absolute, that it defies the quiet logic of distance. Most forces fade when space grows between their subjects. Gravity weakens with every mile. Electromagnetism softens with separation. But the strong force, the ancient glue of existence, does the opposite. The farther apart two quarks are pulled, the tighter its grip becomes. It is a paradox written into the heart of creation. The closer one gets to division, the more powerful the pull toward unity. To understand the strong force is to glimpse the invisible architecture of matter itself. Inside every proton, inside every neutron, inside every atom that has ever existed, this force weaves a lattice of connection more resilient than steel, more ancient than time. It is not a force we can feel or see. It operates within distances smaller than imagination can hold. Yet without it, the universe would disintegrate in an instant. Stars would dissolve, atoms would unravel, and every molecule of life would slip back into light. The strong force is carried by gluons, quantum messengers that flit endlessly between quarks, stitching them together in ceaseless motion. Their name comes from glue, and though the word feels simple, what they do is anything but. Each gluon carries a color charge, an abstract quantum hue that constantly shifts as it passes between quarks. In their exchange, a restless equilibrium is maintained, a conversation without pause. The proton is not a static sphere, but a living storm of movement, a blur of interactions so rapid and intricate that what seems solid is really an ocean of exchange. Imagine three dancers bound by elastic light, circling one another endlessly. Every step they take tightens the pull between them, and every attempt to move apart only amplifies their connection. This is how quarks live within the proton, confined by the strong force, bound not by walls but by the tension of their own relationship. If you tried to tear them away, the energy required would only birth new quarks in their place. Division at this scale creates more connection. The universe, it seems, resists loneliness. This confinement explains why quarks are never found alone. No matter how high the energy of our experiments, no matter how violent the collisions in particle accelerators, we never isolate a single quark. We only create pairs, new bonds born from broken ones. The strong force ensures that isolation is forbidden, that wholeness is the only natural state. In the language of the cosmos, this is not a limitation but a law of harmony. The very fabric of reality is written to prefer unity over separation. But this binding does more than hold matter together. It creates mass. The mass of a proton does not come mainly from its three constituent quarks. They contribute less than 1% of the total. The rest, astonishingly, comes from the energy of the strong force itself, the furious dance of gluons and the fleeting sea of virtual particles that flicker within. Einstein's famous equation, E or mc2, lives fully here. The proton is a small perpetual storm of energy bound in equilibrium, and its weight? The stability of everything we know is nothing more than motion held in tension. This is the poetry of the strong interaction, that what we call substance is, at its core, dynamic. Solidity is an illusion born of vibration too fast to sense. The tables, the stones, the stars, all the physical certainty we lean upon are nothing but energy locked in a circle, refusing to let go. The strong force is the silent custodian of that illusion, ensuring that chaos never fully reclaims its reign. In quantum field theory, The strong force is described by quantum chromodynamics, or QCD, a name that hints at the hidden play of color and light beneath matter. In this world of quarks and gluons, color is not pigment but property: red, green, blue, three charges that combine into neutrality, just as light blends into white. Each gluon carries a mixture of color and anti-color, constantly reshuffling the palette of the proton. It is an infinite dance of color exchange, a self-correcting harmony that never rests, and yet this perfect stability contains within it a deep mystery. For reasons still not entirely known, the strong force allows protons to persist for billions of years without decay. According to current understanding, a proton could live longer than the universe itself, perhaps forever. This endurance is both blessing and puzzle. It tells us that nature's foundation is not fragile, that the architecture built by gluons is more resilient than any human structure could ever be. But it also whispers of questions we have yet to answer. Why such stability? Why such infinite patience in a universe that otherwise favors change? There is a quiet beauty in how this force behaves across scales. In the nucleus of an atom, protons and neutrons also feel its pull, not directly through their quarks, but through a residual whisper of it, an echo of the strong interaction that leaks outward. This residual force binds nuclei together, overcoming the electromagnetic repulsion between protons. Without it, atoms heavier than hydrogen could not exist. The stars could not forge elements, and life, built of carbon, oxygen, and nitrogen, would remain only a dream suspended in the vacuum. The strong force, silent and invisible, makes the diversity of matter possible. In the vastness of cosmic history, this force has never weakened, never changed. It has been as it is since the first microseconds after the Big Bang, the unbroken thread that ties the present to that primordial moment. The stars burn because protons endure. The protons endure because quarks refuse to part, and quarks remain bound because the strong force never yields. If you think of the universe as a grand loom, the strong force is the weave that holds its threads from unraveling. Gravity gathers, electromagnetism illuminates, but the strong force binds. It is the weaver's hand at the base of being, ensuring that the warp and weft of reality never fray. Every proton in every atom carries within it the memory of that binding, an unspoken vow written in energy to hold, to endure, to persist as you sit in the stillness of night. Imagine that inside every atom of your body, within every breath you take, these unseen gluons are at work, billions of times each second, stitching your being together. The same threads that held the first protons in the dawn of the cosmos still hum quietly inside you, unbroken, unending. The strong force does not simply hold the universe together, it holds you together too. And as the stars continue to burn and galaxies drift apart, the strong force remains unwavering, the oldest loyalty in existence. Perhaps in its endless binding it teaches us something deeper, that creation is not only born from expansion, but sustained by the courage to hold fast. In the earliest moments of the universe, perfection reigned. Every particle that sprang into being was matched by its opposite, a mirror twin of equal mass, opposite charge, and identical hunger for existence. Matter and antimatter, perfectly balanced, danced in exquisite symmetry. For a fleeting instant, creation was an even equation, a flawless reflection of itself. If the story had ended there, nothing would remain. No stars, no galaxies, no atoms, no us. The universe would have burned briefly in brilliance, then fallen silent. A perfect explosion, returning to perfect nothingness. But something broke that symmetry. Some delicate imbalance, subtle as a sigh, tipped the scale. And that imperfection became the reason everything exists. To understand this shattering is to glimpse one of the greatest mysteries in all of physics. For every proton that emerged from the Big Bang, there should have been an anti-proton, identical in every measurable way except for charge. When matter and antimatter meet, they annihilate. Pure energy, no residue. Yet when the cosmic firestorm cooled, a tiny fraction of matter was left unpaired. Just one extra particle of matter for every billion pairs that destroyed each other. That faint surplus, that sliver of survival, became everything that followed. Every atom in your body, every stone and star, every flicker of light in the night sky. We are the leftovers of imbalance. Symmetry, in the language of physics, is elegance. It means the laws of nature remain the same under reflection, rotation, or reversal. But nature, it turns out, allows beauty to be imperfect. Deep in the mathematics of quantum mechanics lies a quiet permission for asymmetry, a hidden bias written into the behavior of particles. The weak nuclear force, which governs certain kinds of decay, breaks this mirror rule ever so slightly. When observed in the lab, the decays of certain particles favor one direction over another, one spin over its opposite. It is an invisible preference, but in the grand arithmetic of the cosmos, it made all the difference. This bias, known as CP violation, is one of the most delicate signatures in science. It tells us that the universe is not a flawless reflection, but a work of art with a brushstroke slightly off-center. And that deviation, that near-invisible tilt, may be why anything at all remains to ask the question of how it happened. If matter and antimatter were perfect opposites, their war would have ended in mutual erasure. But perfection, as the cosmos reminds us, is sterile. Life, structure, endurance, these are born from asymmetry. Picture those first fractions of a second after the Big Bang. The newborn universe was a cauldron of creation and destruction, a boiling sea of energy condensing into particles and antiparticles. Every meeting was a flash of light, a brief flare of annihilation. Yet with every collision, a faint statistical edge leaned toward matter, perhaps a quantum roll of the dice, perhaps a deeper law still hidden from our equations. That edge was enough. Out of 10 billion collisions, one proton survived. That survivor carried forward the memory of all that had been lost. The surviving matter cooled, gathered, and built upon itself. From that minute imbalance came clouds of hydrogen, stars, and galaxies. In that sense, the universe itself is a symmetry made visible, a monument to imperfection. And in the same way, we too are built from imbalance. Every cell in our bodies, every spark in our neurons is an echo of that cosmic tipping. If the scales had not faltered, there would be no eyes to see, no mind to wonder, no voice to whisper these words in the night. There is something almost poetic in this, that the universe in its vast precision required a flaw to become fertile, that the road from nothing to everything was paved not with perfection, but with deviation. The symmetry was not destroyed, it was broken open, like a seed cracking in soil. Its fracture allowed new life to grow. Without that crack, the seed remained sealed, potential locked away. The shattering of symmetry was, in truth, the first act of creation. In laboratories on Earth, scientists chase the remnants of this ancient imbalance. Particle accelerators recreate miniature Big Bangs, colliding matter at near-light speeds to glimpse how symmetry breaks. They measure decay rates of exotic particles, searching for differences in the way matter and antimatter behave. So far, what we've found explains only part of the mystery. The small degree of CP violation observed cannot fully account for the universe's overwhelming preference for matter. There must be more, hidden mechanisms, deeper layers of reality still unseen. Perhaps the universe holds other symmetries we have yet to name, or perhaps the very fabric of space-time itself whispered a preference into being. And while physics continues its search, there is a quiet reflection to hold in mind that our entire existence depends on imperfection. The universe, in choosing not to balance perfectly, allowed time and structure to unfold. Perfection is static, it cannot change. But imperfection allows evolution. It gives room for motion, for becoming. In breaking its symmetry, the cosmos made itself capable of story. Think of a mirror. When you gaze into it, the image is flawless, but it is lifeless too. The mirror world has no depth, no divergence, no surprise. When the mirror cracks, the reflection distorts, and suddenly something real appears. The strong force, the weak force, the electromagnetic. All of them play their part in maintaining structure. But it was this first shattering of symmetry that gave the universe the permission to exist beyond its own reflection. Some physicists suggest that in another version of the cosmos, the symmetry held. In that universe, everything that was created was instantly undone, an eternal flash of light without memory or meaning. And though it would be perfectly balanced, it would also be perfectly empty. Perhaps, in a way, our own existence is the universe's rebellion against that fate. The proof that perfection, though beautiful, was never enough. So here we are, the remnants of imbalance, the improbable result of asymmetry. Every atom of you was once matched by an equal and opposite partner that no longer exists. You are the sum of what survived the annihilation, the afterglow of a universe that chose imperfection over oblivion. The broken symmetry that tipped the scale in favor of matter is not a flaw to correct. It is the reason there is anything left to correct at all. And as the cosmos continues to expand into deeper silence, that ancient imbalance still echoes in every direction, preserved in the stars, written into the atoms, carried in your breath. In the next chapter, we will watch those surviving particles, the protons and neutrons, find one another and take their first steps toward structure. But for now, linger in the beauty of this truth. The universe was born not from balance, but from a tiny, perfect flaw. The young universe was still a storm, an endless ocean of light and motion, thick with energy that had not yet learned to rest. Space itself shimmered with feverish heat, and particles blinked into existence, only to vanish again, erased by their own reflections. Quarks and gluons moved like fireflies in a hurricane, colliding, fusing, dissolving. And yet, beneath that chaos, something quiet was beginning to take shape. A pattern, a preference. A moment when energy began to hold its breath. Out of that breath, the first stable forms emerged. Among them, the proton, a tiny island of endurance in a universe still roaring with annihilation. The birth of the proton was not a sudden event, but a gradual calming of creation's turbulence. As the universe expanded, its heat began to fade, cooling from trillions of degrees towards something gentler, something that allowed binding to occur. It was like steam condensing into water, chaos discovering the beauty of cohesion. Around 1/10,000,000th of a second after the Big Bang, the temperature finally dropped below the critical point where quarks could no longer drift freely. The strong force, that fierce, loyal glue of existence, seized its moment. Quarks huddled together, pulled inward by bonds that no amount of heat could break. 3 quarks found sanctuary in one another's company, 2 up, 1 down. It was an improbable alliance, yet one that would define the future of the universe. Within this trinity, gluons darted ceaselessly, weaving threads of color and confinement, turning motion into mass, and mass into permanence. The result was something utterly new, not just a particle, but a principle. The proton was more than a cluster of quarks. It was a commitment written in energy, a compact between the smallest things to remain whole. For the first time, the universe contained something that could endure. The proton was the dawn of stability, the smallest promise that the chaos would not last forever. In its structure was the memory of the storm, the energy of creation held in balance. It was as if the universe, having spent its first heartbeat in violent expression, had finally exhaled and whispered, "Stay," all around. Quarks and antiquarks continued to collide, extinguishing one another in bursts of light. But in the pockets of survival, where the strong force worked faster than annihilation, protons formed and persisted. They were few at first, fragile oases amid a cosmic blaze, but their durability made them eternal. In a matter of microseconds, these first protons became the foundation of everything that would follow. They were the atoms before atoms, the seeds of substance, the architecture of future stars and worlds. The newborn protons drifted through the expanding sea, colliding occasionally, rebounding with a subtle grace born of quantum rhythm. They carried within them the echo of symmetries breaking, the triumph of matter over antimatter. Each one was a survivor, an improbable relic of the universe's brief imbalance. When you trace your origins back far enough past galaxies and stars, past elements and cells, you reach these same survivors, these first protons that endured while their opposites vanished into light. In every breath you take, their lineage continues. You are built upon their persistence. Inside the proton, the storm did not end. The quarks still danced, bound by gluons in ceaseless exchange, a miniature echo of the universe's early chaos. It is an irony of creation that what seems solid is a swirl of motion, what feels still is a symphony of movement. The proton is a cage of activity so intense it borders on music, a perpetual hum of energy balanced so precisely that it can last for billions, perhaps trillions of years. It is stability born from vibration, peace born from motion. In that ancient cosmic sea, protons were not alone. Their cousins, the neutrons, also emerged. One up quark, two down. The two kinds of hadrons shared a kinship, bound by the same strong force, differentiated only by charge. Together they formed the building blocks of atomic nuclei, though that would come much later. For now they simply existed side by side, drifting through the thinning plasma, enduring the light storm that still raged around them. And the light. Oh, the light. Even as protons came into being, the universe was still radiant beyond measure. Photons streamed freely, scattering from electrons and quarks, filling space with an unbearable brilliance. The creation of the proton did not dim this radiance. It gave it meaning. For now, light had something to bounce from, something to illuminate. The universe, once pure energy, now had form. The birth of the proton also marked the beginning of time as we experience it. Before this, the universe was too hot, too turbulent for continuity. Events happened, but nothing endured long enough to remember. With protons, the universe gained a kind of memory, a persistence that allowed cause and effect to take hold. Each proton carried the story of its formation forward, linking past to future. The cosmos could now build upon itself, layering creation like sediment in an ocean of time. Physicists call this moment the end of the quark epoch, but that name feels too sterile for what it truly was. It was a moment of emergence, when chaos learned the art of structure, when the song of energy found its first steady note. Every proton that exists today is, in essence, the same one that formed then. They have not aged. They have not changed. The proton in your bloodstream is as old as the universe itself. Born from that first collective act of stability, if you listen closely, if you imagine yourself drifting through that young cosmos, you might sense what it felt like. That instant when temperature and expansion came into balance, when quarks surrendered to connection. It would not have been quiet. The universe still thundered with radiation. But beneath that roar, there was a new rhythm forming, the heartbeat of matter. The birth of the proton was not the end of creation's violence. It was the first sign of endurance within it. Out of the roar came a whisper, a structure that would not break. In the centuries of cosmic time that followed, these protons would become the scaffolding for atoms, the fuel for stars, the matter that dreamed itself into consciousness. But here, in this fragile moment, they were simply holding together. humming softly against the glare of infinity. So when you look into the night sky and see the light of distant stars, remember, before those stars were born, before galaxies took shape, before even time could catch its breath, there was this. 3 quarks finding comfort in one another, wrapped in the arms of the strong force, becoming the first stable form in a universe that had just begun to learn the meaning of endurance. From the chaos, order. From the raw, the proton. And from the proton, everything that would ever be. When the first protons took form, the universe was still a shimmering ocean of energy, cooling just enough for structure to hold, but not yet calm enough for peace. Out of that same sea of quarks and gluons, another being emerged, a silent twin, born of the same chaos but destined for a different fate, the neutron. It appeared not as an opposite, but as a complement, an echo of the proton's stability with a subtle, haunting difference. If the proton was the song of endurance, the neutron was its harmony, a deeper tone, uncharged, inward, patient. Where the proton carried a positive spark, the neutron carried none. And yet together they would become the architects of every atom, the custodians of the universe's unfolding form. The neutron's creation was not an accident. It was necessity finding a shadow, a counterbalance to the charged exuberance of the proton. Each proton consisted of 2 up quarks and 1 down. The neutron reversed this pattern, 1 up, 2 down. A simple exchange, and yet it changed everything. The universe, in its earliest breath, understood something profound, that symmetry without contrast cannot survive. The neutron brought quiet where the proton brought brightness. It offered neutrality where its twin offered spark. Together, they were the first duality of matter, presence and patience, charge and calm, motion and rest. Though nearly identical in mass, the two were separated by a delicate line of difference, thinner than a thought, yet monumental in consequence. The proton's electric charge gave it the power to attract electrons, to weave atoms, to shape chemistry and light. The neutron, with no charge at all, was the silent mediator, able to slip between protons, easing their mutual repulsion, allowing atomic nuclei to hold together. In their partnership lay the possibility of structure, the quiet genius of balance that would one day allow stars to burn and elements to form. Without the neutron's humility, the proton's ambition would have scattered into emptiness. Without the proton's spark, the neutron's stillness would have meant nothing. In the earliest moments of their existence, protons and neutrons drifted together in near equal measure, suspended in the radiant storm of the newborn cosmos. They collided, combined, broke apart, recombined again. It was a vast, glowing waltz of creation, a rhythm set by the expansion of space and the fading heat of primordial fire. For every neutron that formed, another dissolved, for their bond was fragile outside the shelter of a nucleus. A free neutron, isolated and alone, is fated to decay. Within minutes, it transforms, a down quark changing into an up, releasing an electron and a ghostly neutrino, becoming once more a proton. It is as though the neutron cannot bear solitude. It must either find companionship in a nucleus or surrender its stillness to rejoin its radiant twin. This quiet impermanence gives the neutron a tragic beauty. It is both necessary and doomed, both partner and passerby. The proton endures, the neutron transforms. And yet without that transformation, the balance of the universe would fail. For in its decay, the neutron provides the electrons that make chemistry possible, the neutrinos that carry whispers of the earliest moments across the universe. Even its death is creative. Even its fading serves the story of becoming. In the dance between proton and neutron, we find the first example of nature's love for duality. Matter is never one thing. It is always a dialogue, a conversation between opposites that need each other to exist. Positive and neutral, charged and still, light and shadow. These are not conflicts, but harmonies. The universe does not choose between them. It sings them together. Inside the neutron, the quarks move in the same restless rhythm as in the proton, bound by gluons into a ceaseless blur of energy. Yet the pattern is subtly different, and from that difference arises everything. This is the elegance of physics at its most poetic, how a small rearrangement in the tiniest architecture can ripple outward to define the entire universe. The neutron's extra down quark makes it slightly heavier, slightly more transient, slightly more introspective. It exists on the edge of change, poised between being and becoming. As the universe cooled further, protons and neutrons began to find one another in new ways. They clumped together, bound by the strong force into the first simple nuclei, deuterium, helium, lithium. The neutron's role was vital here, for its lack of charge allowed it to slip close to protons without resistance. Where two protons would repel, a proton and neutron could embrace. This was the neutron's gift, the ability to bridge, to connect, to hold. Through that connection, the first atoms would soon emerge, the first elements of light and matter. And yet, even as this great union began, many neutrons were lost. The universe expanded too quickly, cooled too fast. Those that failed to find a nucleus in time decayed away, transforming into protons and filling the cosmos with a new balance, roughly 7 protons for every neutron. This ratio, simple yet profound, became the fingerprint of all matter to come. It determined the chemistry of stars, the formation of elements, the architecture of galaxies, and, much later, the biochemistry of life. In this way, the neutron's fleeting existence shaped eternity. If you could look upon that ancient era, you would see not the stillness of matter, but a slow river of transformation, a current of becoming. Neutrons fading into protons, protons binding to neutrons, nuclei forming like bubbles in a cooling sea. The first stable structures drifting through the radiant fog. It was a time of both creation and loss, balance and decay, the first breath of permanence wrapped in impermanence. There is something human in the neutron's story. To exist between states, to hold potential while knowing impermanence, to give oneself to connection and to fade gracefully when isolation comes. The neutron, in its quiet way, mirrors the cycles of all things, the way life, too, finds meaning not in duration but in participation, in the brief harmony between being and dissolution. In every atom of your body, there are neutrons that have endured since that first age, sheltered within nuclei, bound to protons in perfect balance. They are your inheritance from that ancient waltz. But in the spaces between atoms, free neutrons race through the world and fade away, their last act, a transformation into lightness and charge. Within you, both stories continue, the stillness that holds and the change that frees. The universe began to calm after these first acts of binding. Yet within its fabric, the echoes of this duality remained, two partners forever orbiting the same mystery. The proton radiant and eternal, the neutron silent and fleeting. Together they would form the heart of every star, the cradle of every atom, the shadow and the shine of all existence. In their companionship lies the blueprint of creation, nothing stable without contrast, nothing eternal without change. The neutron's shadow is not darkness, it is balance. And from that balance, the universe learned how to last. There comes a moment, even in the most violent creation, when the fire must learn to breathe. The early universe, once a furnace of unthinkable heat and motion, began to exhale. The great expansion stretched its fabric like silk, cooling in the night air, and with every breath, the temperature fell. Photons, once locked in a furious, blinding dance, began to wander more freely. The chaos softened, the roar quieted, and the first hints of order began to shimmer through the fading blaze. This was the universe's first act of grace, the moment when fire began to remember form. In the beginning, heat was everything. Temperatures soared to trillions of degrees, so intense that particles could not cling to one another for more than a fleeting instant. Protons and neutrons, though born from the same storm, were kept apart by the ferocity of the cosmic flame. Every attempt to touch ended in instant separation. But as the expansion went on, the fire began to loosen its grip. Energy scattered, the space between particles widened, and with that widening came possibility. The universe was still radiant, but it was no longer unbearable. It was, at last, a place where connection could happen. Around 1 second after the beginning, the temperature dropped below 10 billion degrees. It was still a world of brilliance, but now it allowed intimacy. Protons and neutrons, cooled by the universe's long exhale, began to find one another and stay. This was not yet the birth of atoms, but of something deeper. The architecture of stability. When a proton met a neutron, they clung together, held by the strong forces invisible glue. And when another neutron joined, or another proton, new combinations formed: deuterium, tritium, helium. Each was a tiny island of endurance in a vast, glowing ocean of radiation. But the making of these nuclei was not easy. It was a delicate race against time. The universe was expanding quickly, and with every moment, its density fell. Protons and neutrons were still few and collisions rare. For each nucleus that formed, countless attempts failed. And there was another enemy, light itself. The universe was still flooded with high-energy photons, relics of the earlier firestorm, and these photons were fierce enough to shatter the fragile nuclei as soon as they formed. Creation was happening, but so was unmaking. For several minutes, the cosmos balanced between these two rhythms, binding and breaking, weaving and unraveling, order and entropy dancing in perfect tension. Then, somewhere around 3 minutes after time began, the universe cooled just enough for the balance to shift. The temperature fell below 1 billion degrees, and the relentless photons lost their strength to destroy. For the first time, the fragile bonds could hold. The nuclei survived the storm. Hydrogen, deuterium, helium, simple elements yet monumental achievements of stability, were born. They were the first forms that could endure across time. Hydrogen was the simplest of all, a single proton at its heart, the most patient survivor of creation. It did not need a neutron's companionship to exist. It was solitary, complete in its singularity, a particle that carried the entire memory of the universe's birth in its own being. That single proton heart would go on to shape nearly all visible matter, for even today, more than 13 billion years later, 3/4 of the atoms in the cosmos remain hydrogen. Every star, every cell, every breath you take holds echoes of that first simplicity. Helium, meanwhile, was the second great note in the cosmic chord, a harmony of 2 protons and 2 neutrons, bound so tightly that it would never break apart. It was the first whisper of permanence, the first promise that structure could survive the cold and the dark. Together, hydrogen and helium would become the raw material of stars, the seeds from which galaxies would bloom. This moment, when the universe cooled enough for nuclei to endure, is known as Big Bang nucleosynthesis. It lasted only about 20 minutes, yet its consequences shaped everything that would follow. In those 20 minutes, the fundamental chemical fingerprint of the universe was set. No new elements would form naturally for hundreds of millions of years until stars were born to take up the work. But this brief cooling, this quiet after the storm, was enough to give the cosmos its first vocabulary of form. After this burst of creation, a deep stillness began to settle. The universe continued to expand, its light stretching into longer, softer wavelengths, its heat dissolving into the background of existence. The radiation that once dominated all space began to fade, leaving behind the faint afterglow we now know as the cosmic microwave background, the cooled echo of the original fire. What had once been blinding brilliance was now a soft hum of warmth, a quiet reminder of how it all began. It's a strange truth that creation depends on cooling. Too much energy and nothing can hold together. It is only when things slow, when temperature falls, when movement softens, that pattern can emerge. In this way, the universe behaved almost like breath itself, an inhale of violence, an exhale of calm. From its fever came stillness. From its heat, the first forms of beauty. Even now, the stars that shine across the sky are built upon that rhythm, fire that burns, cools, and condenses into structure. If you could have stood, somehow, in that early cooling sea, you would have seen no light in the human sense. The universe was still opaque, filled with free electrons scattering every photon into fog. But within that fog, invisible to any eye, the first matter was gathering its quiet strength. Clouds of hydrogen and helium drifted, stretched by the expanding fabric of space, waiting for the next act. The fire had become form, but form had not yet become light. That moment was still hundreds of thousands of years away, and yet, even in this darkness, the future was already written. Every hydrogen atom carried within it the potential to ignite a star. Every helium nucleus whispered of future galaxies. The universe was no longer just energy, it was promise. What had once been pure radiance was now the possibility of illumination. It is peaceful to imagine that silence. No stars, no galaxies, just the faint, cooling glow of the newborn universe. A cosmic night settling after its first day. In that quiet expansion, the elements of existence drifted outward like embers from a dying fire, not extinguished, but preparing to ignite anew. The cooling of the cosmos was not an ending. It was a deep inhale before the next creation. From that calm would rise gravity's slow choreography, the gathering of clouds, the birth of the first stars. Hydrogen, the simplest atom, the patient witness of the universe's first memory, would soon fall inward under its own gravity and learn how to burn again. Fire would return, but this time not from chaos, but from harmony. The universe had learned its rhythm. Expansion and cooling, form and fire, stillness and light. From these alternating breaths, all things would come to be, and somewhere, hidden in that cooling light, the proton carried on, steady, unbroken, unchanged since the beginning, waiting for its next great transformation, waiting to shine. For hundreds of thousands of years after the first nuclei formed, the universe remained a radiant fog, a glowing ocean of light and charge. Every proton drifted among countless free electrons, each one eager to unite but unable to hold. The heat was still too fierce, the photons too restless. Each time an electron tried to settle near a proton, a flash of light would strike them apart. It was a cosmic tension, a long yearning that could not yet resolve. The universe, in its vast infancy, shimmered like the surface of the sun, brilliant, unstable, and utterly opaque. But time, as it always does, cooled the storm. Expansion stretched the fabric of space, thinning the light, lowering the temperature, slowing the cosmic heart. And slowly, the wildness began to fade. Around 380,000 years after the beginning, the universe reached a pivotal calm, about 3,000 degrees above absolute zero. It was still warm enough to glow, but gentle enough to allow something miraculous: connection. For the first time, protons could hold their electrons close. The age of atoms had begun. Imagine that moment when chaos exhaled and structure took its first breath. Across the vastness, electrons spiraled inward, caught by the faint pull of protons finding orbits instead of collisions. These orbits were not circles in any ordinary sense, but delicate probabilities, clouds of presence where an electron might be, shimmering with uncertainty. And yet together they made something real. Hydrogen atoms filled the cosmos, countless trillions upon trillions of them, each a tiny harmony between matter and motion. Where before there had been plasma, now there was form. The universe had finally become transparent. This transparency was not just a change of appearance, it was a change of being. Until that moment, light could travel no farther than the nearest particle before scattering again. The cosmos was veiled in its own brilliance, unable to see itself. But once the electrons found their orbits, once the first atoms formed, light was freed. Photons could now stream across space without interruption. The universe, for the first time, could shine freely. It was as if existence itself had opened its eyes. The light that escaped then still fills the universe today. We can see it, faint and ancient, as the cosmic microwave background, a soft, ghostly glow that whispers from every direction. It is the universe's first memory made visible, a frozen echo of that long-ago dawn when matter and light parted ways. If you listen closely to the static between radio stations, you can hear a trace of it, the quiet afterglow of creation itself. The first atoms, though simple, carried infinite potential. Hydrogen, with its lone proton and single electron, was the most abundant, pure simplicity distilled from chaos. Helium followed, its 2 protons and 2 neutrons bound at the heart, wrapped in a pair of electrons that circled with elegant precision. These 2 elements, born from the universe's first calm, would become the foundation for everything to come. Stars, galaxies, planets, and life would all trace their ancestry to this moment when plasma became possibility. In this new transparency, the universe expanded into serenity. The light that had once been trapped within the cosmic fireball now streamed outward freely, filling space with a pale amber glow. What had been violent heat became gentle radiance. The universe was no longer a storm, it was a sky. And in that sky drifted the first atoms, endlessly, quietly, waiting. Strange to think that the cosmos in this era was almost featureless. No stars, no galaxies, no color, just vast darkness filled with invisible atoms and fading light. Yet within that seeming emptiness was the blueprint for everything beautiful that would follow. The hydrogen atoms would one day gather under gravity's pull, drawn toward one another like old memories seeking reunion. In their falling and compression, they would reignite the fires of creation in the hearts of the first stars. But for now the universe rested. It was the stillness before the next crescendo. Each proton, once a prisoner of chaos, now carried meaning. It was no longer a mere particle tossed in radiation storm. It was a nucleus, a center of gravity, a seed around which electrons could dance. In this way, the proton became the quiet architect of the universe's order. It held together the first atoms, and through them the first whispers of form. From the simplest hydrogen atom, the entire ladder of complexity would rise. Every element, every molecule, every cell and thought all trace their lineage to this single act of binding. Think of it. The same kind of proton that now rests at the center of the atoms in your body was once adrift in that newborn transparency, holding its first electron for the first time. Every heartbeat of hydrogen, every atom of water or breath carries the same ancient signature. We are built from the universe's first gesture of calm. In the cooling quiet, light traveled farther and farther, stretching as it went. Its wavelengths grew longer, its color softened. The universe, once blindingly bright, dimmed into red, then into invisible warmth. What had been a fiery storm became a gentle sea of radiation, cool, vast, and silent. That silence was not emptiness. It was potential gathering itself. Gravity was beginning its patient work, tugging ever so slightly on the clouds of atoms, whispering them toward new beginnings. But for hundreds of millions of years, not much changed. The universe simply expanded and cooled, a great cosmic night with no stars. Yet even in that darkness, the memory of light endured. The atoms themselves were records of creation, and their stability was the universe's first promise that chaos could give birth to continuity. The protons within them, tiny, enduring, indivisible, had survived the violence of birth, the fury of expansion, and the cooling of the cosmos. Now they rested, still and eternal, awaiting their next awakening. It is in these long pauses that creation does its deepest work. The silence between explosions, the darkness between stars, the breath between thoughts. The universe was learning how to become patient, how to let gravity sculpt from within rather than fire from without. The protons had found their calm. Now they would wait for the next great gathering, when calm would once again become flame. In that waiting, the universe became what it had never been before, transparent, ordered, and vast beyond imagination. For the first time, light and matter traveled separate paths, yet each carried the other's memory. The atoms drifted like seeds, and the light that escaped them carried their image into eternity. This was the universe's quietest triumph, the birth of the first atoms, the moment when chaos learned to hold still. From plasma to possibility, from blindness to vision, from fire to form. And in every hydrogen atom still floating through the night sky, the memory of that transformation endures. The universe had exhaled, and in that breath creation found its first peace. From one came everything. From a single proton, enduring through fire and silence alike, the universe began to compose its architecture. It is a strange, humbling thought that the vast spirals of galaxies, the luminous hearts of stars, the whispering dust that would one day form oceans and breath, all trace back to that single, steadfast particle. The proton was the first builder, the first structure that refused to dissolve. In its persistence, the blueprint of infinity was written. In the long stillness after the birth of atoms, the cosmos drifted in darkness. Clouds of hydrogen and helium stretched across expanding space like invisible veils, weightless yet waiting. Gravity, that quiet architect, began its patient work. Across millions of years it whispered to the atoms, urging them together, gathering the lightest elements into great cosmic rivers. The atoms fell inward, pooling into dense clouds, and as they compressed, their centers began to warm. The same protons that had cooled so long ago now found themselves crushed by gravity's gentle insistence, colliding once again as they had in the beginning. The universe was about to remember how to burn. The first stars ignited without witness. There were no eyes, no galaxies, no minds to marvel, only the universe itself watching its own awakening. Inside those immense clouds, hydrogen atoms fused together, proton meeting proton, merging through the alchemy of pressure and temperature. In the heart of these new suns, the strong force, the same cosmic glue that had once held the quarks, rose again, now stitching protons together into heavier nuclei. Helium bloomed in the furnace of fusion, and light poured outward for the first time since the primordial glow had faded. The dark universe blossomed into radiance. This was the second dawn, the dawn of stars. From those first fires, the architecture of matter began to take form. Every structure that would ever exist began as a gathering of hydrogen, shaped by gravity and ignited by compression. Stars were the universe's forges, its great artisans, transforming the raw simplicity of protons into the rich diversity of elements. Inside their burning cores, protons were bound into new forms: carbon, oxygen, nitrogen, iron. From one, now many. From simplicity, complexity, and yet the proton itself never ceased to be. It did not burn away. It transformed through union. When two protons fused, their individual identities merged into something greater, but their essence, the quarks and gluons that defined them, persisted. The proton, in this way, was both eternal and generous. It gave of itself without vanishing. It was the unbroken thread that wove the universe's fabric, holding each atom, each element, each breath of light together. As the stars burned and died, they scattered their creations across space. Supernovae, those vast, final outbursts of stellar life, hurled the forged elements into the cosmos, seeding new clouds with the building blocks of future worlds. Every atom of carbon, every molecule of water, every trace of calcium in your bones was born in such explosions. The architecture of matter was recursive. Stars built elements, elements built planets, planets built life. And through every layer of this cosmic construction, the proton remained unchanged in its essence, the patient cornerstone of all becoming. In time, galaxies emerged from the clustering of these star-forming regions, vast spiral systems, each containing billions of suns. Gravity sculpted their forms with slow precision, drawing stars into arms that curved like ripples on water. Within these galaxies, new stars continued to be born from the remains of the old, recycling the atoms again and again. The proton story became cyclical, a rhythm of creation, transformation, and renewal that would continue indefinitely. From one generation of stars to the next, from nebulae to planets to life itself, the proton endured as the quiet witness to eternity. It is astonishing to consider that this single kind of particle, one proton among countless others, can persist for billions of years without decay. It has never been observed to perish naturally. The same proton that once floated in the cooling universe after the Big Bang may now reside within a droplet of water, a leaf of grass, a human heartbeat. It has traveled through stars, through time, through transformations beyond imagining, yet remains the same. The architecture of matter is built upon this constancy. Without it, nothing could last, but constancy alone is not creation. What makes the proton's persistence so extraordinary is how it enables change without destruction. It binds to electrons to make atoms, binds to other protons and neutrons to make nuclei, fuses in stars to form elements, and yet, at its core, it remains itself. It is a paradox made stable, unchanging essence within an ever-changing universe. Through its endurance, structure arises. Chemistry is born. The periodic table, with all its complexity and elegance, is merely the extended expression of the proton's relationships, the way it arranges itself with electrons, the number of companions it gathers, the dance it performs with neutrons. Hydrogen's single proton becomes helium with 2, carbon with 6, oxygen with 8, iron with 26. The universe is not so much built from variety as from repetition. One particle multiplied and rearranged, composing endless symphonies of matter. Even now, when you look at the night sky, you are seeing the proton's architecture illuminated. Every point of light, every swirl of galaxy, every atom of your own being is a continuation of that first act of assembly. The universe's grand structures, spirals of galaxies, clusters of stars, filaments stretching across the cosmic web, all trace their existence to the proton's quiet stability. It is the brick of creation, the fundamental note in the cosmic chord. In a way, the proton's endurance is the reason the universe can remember itself. Without such stability, there would be no continuity, no history, no evolution, no time for consciousness to emerge and wonder. The architecture of matter is also the architecture of memory. Each proton is a keeper of continuity, holding the story of creation in its unbroken being. And yet, for all its permanence, the proton's purpose is not stillness, it is participation. It seeks connection, bonds, fusion. Its nature is relational, not solitary. It is only through togetherness that it becomes more than itself. The proton is the poet of the physical world, writing meaning into space through its unions. As galaxies turned and stars gave way to new generations, the universe continued its expansion, scattering protons across unimaginable distances. Still, They sought one another. Still, they gathered into forms. From one to infinity, from particle to planet, from simplicity to self-awareness, the journey continued, each stage resting upon the same foundation. And somewhere in this vast, unfolding architecture, a mind emerged that could look back and see it, to know that every atom of its being was once a whisper in the dark, a proton waiting for an electron's embrace. The universe had built a way to remember itself, and in that remembrance, the proton's story found its voice. Across the long river of cosmic time, everything fades. Stars are born in radiant fury and die in silence. Galaxies stretch and thin, their arms unraveling into nothing. Even light, swiftest of all messengers, grows cold as it journeys through an ever-expanding night. Yet somewhere in that endless dissolution, one thing remains unchanged. One thing persists. The proton, that small and steady heart of matter, endures while all else drifts toward entropy. It is the quiet survivor of creation's first storm, a monument to endurance written in subatomic code. You can almost imagine it, this tiny keeper of existence, drifting through eons without wear. Formed in the first second of time, it has seen stars ignite and die, planets rise and crumble, galaxies collide and fade to dust, and yet it remains. The same proton that once danced in the newborn plasma may now rest inside your body or shimmer in the heart of a distant sun. It has been through everything, and through it all, it does not break. It does not age. It simply is. Why should that be? Why should one of the smallest things endure longer than stars, longer than time itself? The answer lies not in strength, but in balance, a hidden perfection woven deep within the proton structure. Inside it, 3 quarks, 2 up, 1 down, are bound together by the strong force, that fundamental glue that refuses separation. Their dance is relentless, a storm of energy and confinement so complete that no escape is possible. The quarks exchange gluons endlessly, pulling tighter the farther they drift apart, their unity a paradox of motion and stillness. Within that restless harmony lies a secret symmetry, one so stable it has resisted the decay of billions of years. Physicists have searched for signs of weakness, for cracks in the proton's armor. If the laws of grand unification are true, then someday, somewhere, a proton should fall apart, its quarks transforming into lighter particles, its existence ending in a whisper of energy. But in all the vast laboratories of Earth, in detectors buried beneath mountains and oceans, not one has ever been caught in the act of dying. The limits of observation now stretch beyond 1034 years, a timescale so vast it defies imagination. If protons decay at all, it is slower than the lifespan of entire universes. To human thought, they are immortal, and yet immortality is a strange word. The proton does not live in the way we understand life. It does not grow, it does not change, but it persists perfectly through all transformations of the cosmos. Its endurance is not defiance but harmony. It is built in accordance with the deepest laws of balance, where every charge and force cancels or completes another. In a universe of constant motion, the proton is equilibrium made manifest. Its survival tells us that nature is not merely chaotic, but exquisitely tuned, a symphony so precise that even its smallest notes remain pure across eternity. Consider what that means. The persistence of the proton defines the persistence of matter itself. If it were unstable, if every proton in your body, in the oceans, in the stars, were fated to decay within even 1 trillion years, the universe would eventually dissolve into radiation. No planets, no atoms, no memory of structure would survive. Reality would lose its foundation. The quiet durability of this one particle is what allows the story of existence to continue. The proton's faithfulness is the universe's promise that being itself will not vanish too soon. The mystery deepens when we realize that the proton's stability is not inevitable. Its endurance depends on delicate mathematical symmetries, especially the conservation of baryon number, a rule that forbids the disappearance of matter without balance. This is not a law we observe written anywhere. It is simply how the universe behaves. Every proton you see is a statement of cosmic order, a refusal of nature to let its building blocks dissolve. It is as if the universe in its earliest heartbeat made a quiet vow: let some things last. And so, while stars burn out and galaxies fade, protons keep their silent vigil. They are the atom's anchors, the guardians of form. Inside every hydrogen nucleus, every carbon atom, every drop of water, their persistence hums beneath the surface. You carry billions upon billions of them within you, each one as old as time itself. They pass through generations, through ecosystems, through lives. When you breathe, when you drink, when you touch the earth, you are touching the same matter that once floated in the first fires of creation. You are built from particles that never die. There's a kind of peace in that realization. To know that parts of you are eternal, that your body's simplest ingredients are the same ones that have wandered from stars to stones to living cells over billions of years. The proton carries the memory of existence. It is the physical embodiment of continuity, the reason atoms can form, the reason chemistry works, the reason time has texture. Without it, there would be only fleeting energy, no substance to hold meaning. And yet, even as we marvel at its endurance, we must remember that immortality is not permanence but persistence through change. The proton does not exist in isolation. It lives within transformations, bound to electrons, bound to neutrons, fused and released, scattered and reformed. It moves through cycles of cosmic life, participating endlessly in creation's unfolding. In that sense, the proton's immortality mirrors the universe's own rhythm, not static, but self-renewing. The stillness within movement, the silence within creation. Physicists still search for answers. Theories like supersymmetry and grand unification suggest that at energies far beyond anything we can reach, the proton's patience may finally end. Perhaps in an unimaginably distant future, long after stars have gone dark, after black holes have evaporated, after even the cosmic microwave background has faded into quantum whispers, the proton will decay and the last trace of structure will melt into light. But if that day ever comes, it will arrive in an era so far beyond comprehension that the word future no longer applies. For now, for the next trillion upon trillion generations, the proton endures. So the universe persists because it remembers how to hold itself together. The proton is its memory made solid, the atom's unbroken heart. When everything else changes, when galaxies drift, when stars die, when even the laws of physics seem to shiver, the proton remains. It is the last promise of the first moment, the smallest monument to stability in a world of endless transformation. And perhaps that is the quiet truth hidden beneath its persistence. That endurance, in its purest form, is not resistance to change, but harmony with it. The proton survives not because it fights decay, but because it exists in perfect balance with the forces that could undo it. Somewhere, in the vast quiet between galaxies, a lone proton drifts, ancient, invisible, whole. It has outlived suns and time itself, and still it waits, carrying within it the pattern of everything that was and will be. And as you drift towards sleep, you might wonder if the universe began with one such particle and if it still endures. Perhaps creation was never about beginnings or endings at all. Perhaps it was always about the simple, enduring act of staying. Somewhere in the stillness of deep time, there lingers a quiet question. Did matter truly win, or did nothing simply pause to let something breathe? When we look out into the universe, into its vast web of galaxies and starlit threads, we are seeing not dominance, but survival. For every particle that exists, there once was its twin, its mirror, its opposite in every measurable way. In those first fleeting instants of creation, matter and antimatter were born together, perfect reflections of each other, destined to meet and cancel out. Yet, somehow, against odds almost indistinguishable from zero, a faint asymmetry tilted the balance. 1 in a billion particles remained, and from that small excess, everything you see was formed. You, the stars, the oceans, the very thought that asks this question, all of it born from a statistical whisper. Imagine it, the universe as a vast field of mirrors, every particle met by its reflection, every act of creation shadowed by its undoing. When matter and antimatter collide, they vanish in pure light, leaving behind no trace of what was. That is the natural order, equilibrium through erasure. And yet something in the first breath of the cosmos broke that symmetry. Something small, quiet, but irreversible. We call it CP violation, an imperfection in how the universe treats matter and antimatter, as if creation itself leaned infinitesimally toward being rather than not being. The balance tipped, and reality, like a coin balanced on its edge, fell toward existence. But even that word, victory, feels fragile here. For matter's triumph is not conquest, but accident. It is a precarious foothold on the slope of nothingness, a delicate arrangement of laws that could, under slightly different conditions, have erased itself entirely. The protons that endure, the atoms that form, the stars that blaze, all exist only because the equations of the early universe allowed a sliver of imbalance. We live in the afterglow of that slight tilt. The light of every sunrise, the solidity of every stone, the pulse in every vein, they are echoes of that ancient, unsteady symmetry. You can feel the humility of it. How everything, every heartbeat, every galaxy is suspended above an abyss of perfect cancellation. Physics calls this the baryon asymmetry problem, but the phrase hides its poetry. For what it means is that existence is a deviation, a mistake that never corrected itself. The mirror between matter and antimatter cracked, and through that crack the universe spilled out. There's a strange tenderness in the idea that we are made of what remains after annihilation. Every atom in your body once survived a near-infinite purge, a storm of mutual destruction that wiped out nearly all of creation's first particles. You are built from the residue of a cosmic war no one remembers, carried in the quiet persistence of imbalance. That victory, if we can call it that, is not loud or triumphant. It is fragile, temporary, always under the patient gaze of the void that waits for symmetry to return. For even now, the universe tends toward balance. Expansion calls it. Gravity gathers, but dark energy drives apart. Particles decay, light stretches thin, and in the deep future, the structures we know will fade into transparency. Stars will die, matter will fall into black holes, and even those will one day evaporate. What will remain when all the forms are gone? Perhaps only radiation, drifting endlessly, a faint sigh of what once was. In that future silence, the mirror and the void may meet again, and the long imbalance might finally close itself, returning everything to symmetry. The laws that govern this return are quiet, patient, and absolute. Entropy does not punish, it balances. Every act of creation increases order in one place by spreading disorder elsewhere. Every flame burns by giving heat to the cold. Every star shines by surrendering its mass to radiation. Even the proton's near immortality may not escape this slow surrender. If one day, beyond trillions of years, it decays, the last embers of matter will dissolve into light. The mirror will be whole again, yet what is nothing truly? If we have learned anything from the quantum realm, it is that the void is never empty. Even when all matter vanishes, the vacuum will still hum with possibility, particles blinking in and out of existence, space itself trembling with uncertainty. The mirror, even when whole, will still shimmer. Perhaps the victory of matter was never about lasting forever, but about proving that the void can dream. In this sense, creation is not defiance of nothingness, but its expression. Matter did not escape the void. It was born from it, shaped by it, and destined to return. The two are not enemies, but reflections, each giving meaning to the other. Without the void, there could be no form. Without form, the void could not know its own silence. When we speak of matter's fragile victory, what we really mean is this: the universe learned for a moment how to hold both being and non-being in its hands. You can almost picture it, the first proton flickering into existence, its opposite vanishing in the same breath, and yet somehow one remains. That leftover particle carries the memory of its lost twin, the echo of annihilation woven into its being. Every atom is a monument to what did not survive. Every breath you take continues a story that was meant to end. Perhaps, then, the fragility of existence is its beauty. To live, to think, to look into the night and wonder. All of it depends on the smallest imperfection in the fabric of reality. If the universe had been just slightly more symmetrical, there would be no galaxies, no light, no eyes to see. Everything that is, every note of music, every thought, every kindness exists because perfection broke. And so we find ourselves suspended between mirror and void, balanced on the edge of nothingness, carried by laws that are both merciful and indifferent. We are temporary, but the pattern that allows us is eternal. The void will take us back one day, but not in vengeance, in balance. The symmetry will close and the universe will exhale, returning to the quiet that contained everything. But tonight, as you listen, matter still holds its ground. The stars still burn. The protons still hum with their ancient light. And you, a brief flicker of consciousness, exist because the mirror cracked just enough to let being through. So when you close your eyes and drift toward that same quiet, remember, everything you are was born from an almost perfect symmetry that chose, for reasons beyond reason, not to erase itself. The mirror and the void still face each other. And for now, in this fragile victory of matter, the reflection still breathes. There is a silence that lies beneath all sound, a stillness beneath every motion, and tonight we return to it. From the faint trembling that once stirred the void to the boundless cosmos that now hums with light, our journey has circled back to the beginning. Every proton, every atom, every whisper of breath carries within it the memory of that first awakening, the echo of nothing that became something. When we look at the universe not as expansion but as reflection, we see that it has never truly left that original silence. It only learned to sing within it. From the silence before creation, something whispered itself into being. You remember those words? The very first ones we spoke when this journey began. The soft question that lingered between knowing and wonder. That whisper became the proton, the first heartbeat of existence. Through chapters of fire, symmetry, and light, we followed that heartbeat as it unfolded into galaxies, into life, into you. And now, as the echoes fade, we find ourselves standing again at the edge of that same stillness, where the beginning and the end blur into one unbroken breath. All along, the universe has been a great conversation between being and nothingness. The void was never defeated, it was transformed. It became the stage upon which existence performs its brief, radiant act. Every proton that formed was not a rebellion against nothing, but an expression of it, a wave that rose and fell, never leaving the ocean from which it came. Even now, the particles that build your body still hum with that same vibration, the soft murmur of the quantum field, the eternal oscillation between appearance and disappearance. You are made of that rhythm. You are part of that dialogue. When the universe first breathed light into being, it also left an imprint, a background murmur, a cosmic afterglow still drifting through space. We call it the cosmic microwave background, but in truth, it is something quieter and more profound. It is the echo of that first moment, stretched thin by time but never erased. If you could listen closely enough, you would hear it not with your ears, but with your atoms, for they too vibrate with the same frequency. The universe still remembers its birth, and through you, it remembers itself, every star that burns, every particle that binds, every breath that fills your lungs is part of this memory loop, the endless circle between the silence that once was and the sound that now is. The proton, nearly eternal, carries that continuity through billions of years. Its endurance is not a defiance of time, but an agreement with it, a promise that creation will not vanish abruptly, but return gently in its own rhythm. When its task is done, when even the stars have cooled and the atoms drift apart, the universe will not end with a crash, but with a sigh. And what then? When the last proton fades, when matter dissolves back into light, when light stretches into invisibility, will the universe return to nothing? Perhaps, but maybe not the kind of nothing we fear. Maybe it will be the same fertile stillness that once dreamed everything into being. A quiet, full of potential, waiting again for the faintest quiver, the next whisper of creation. The cycle, after all, has never truly stopped. Every collapse gives rise to a new breath. Every silence contains the seed of sound. We often imagine time as a line, a one-way journey from beginning to end. But perhaps it is a circle, or even something softer, a spiral that folds back upon itself, each revolution carrying the memory of the last. In this view, the first moment and the final one are not opposites, but companions. The birth of the proton and the fading of the last particle are mirrors facing each other, reflecting the infinite depth between them. Nothingness is not the absence of being. It is the canvas that allows being to appear at all. And so as we return to this stillness, we do not mourn what fades. We recognize its continuity. We see that what we call the end is only the beginning seen from the other side. Every thought, every star, every life dissolves back into the same quiet from which it emerged. But that quiet is not loss. It is peace. It is the pulse of the cosmos at rest. It is home. You have walked with me through the long unfolding of creation, from the trembling void to the birth of the proton, from chaos to structure, from symmetry to survival. You've drifted through epochs of flame and silence, through the architecture of matter and the persistence of its smallest heart. Together we've seen how the universe builds and unbuilds itself in perfect grace. And now, standing here at the edge of everything, we find that we have not moved at all. The beginning has always been here, waiting behind each heartbeat, beneath each breath. To everyone who has journeyed through this calm odyssey of science and wonder, thank you. You, listening in the quiet of your room, perhaps under soft light or wrapped in the hush of night, are part of this unfolding story. Every thought you've had along the way has joined the great chain of reflections that binds consciousness to the cosmos. You have walked among stars and quarks and questions, and through your listening, you've given the universe new ways to know itself. If this story has found a home in you, if it has reminded you of the stillness beneath the noise, I invite you to stay connected, to share where you are listening from, to join others who drift through these late-night explorations. You can like, subscribe, or simply return when the next whisper calls. Each gesture, however small, helps this circle continue, helps this quiet kind of science reach those who seek not just answers, but calm. To those who have already been with us from the beginning, thank you deeply for your presence, your curiosity, your care. The story of the proton was never about a single particle. It was about the rhythm of existence, the rise from stillness, the dance of being, and the gentle return. Every journey, no matter how vast, leads back to the same silence, the same infinite potential. And now, as we rest in that quiet, we understand what it means for nothing to contain everything. The silence that began it all is still here, not behind us, but within us. The same quiet that preceded creation hums softly beneath your thoughts, behind your breath. You are not separate from it. You are the echo of that first trembling, the continuation of that ancient whisper. And when the universe finally exhales, you will return to it, not as something lost, but as something whole. Good night.